In this video, we're just going to talk about oxidation numbers and how to figure out some oxidation numbers in a compound. Now, I want to remind you that sometimes some of these elements, they can have different charges. However, there are some charges that might never change, and those charges belong to all our group 1 elements and our group 2 and fluorine and maybe anything with fluorine. Oxygen also doesn't change its charge. And I'm just gonna write down their charges, +1, +2, and aluminum, which might have a +3 charge or always has a +3 charge whenever you see it. Now, why does it matter? Because again, when we're trying to draw out the Lewis structure of some of these elements, some of them, they can expand their last orbital and they can have more electrons in their last orbital. That's why sometimes these charges might change. And however, all these elements that I pointed out in this side over here, all of these, they will have these charges associated with them every single time. So whenever you see them, you have to know that the charges are not going to change. For our first example, we have potassium permanganate, and you don't have to know their names in this point, but I just want to tell you that this is the name of the compound that we're working with. They want us to find the oxidation state for manganese in here, and the way we find it is pretty easy as long as you know what you're doing. And I just want to remind you again that you will always have a periodic table with you. So whenever you're trying to solve all these questions, please have a periodic table available with you. So first, we know that potassium is located in the first column, which means its charge is not going to change, which means the charge of potassium is +1. Now, manganese is the thing that we're trying to find, so we're just going to put an X in there because we don't know what the charge is. Now, oxygen, we know oxygen is something that the charge is not going to change, so we're just going to put a -2 in here. And since you don't see any charges over here, which gives you the total charge, since there's nothing, we know that the whole thing should equal to 0. Now, from here, it's kind of straightforward to just solve it. And we have X, but there is something that might sound kind of challenging, but it's something that's really easy, and it's something that should make sense to you. Because we have 4 oxygens, the oxidation state for oxygen should not be -2. It should be 4 times -2 because we have 4 oxygens in here and we have to account for it, which means we're just gonna do 4 times -2 equals 0. Now, from here, we just have to solve for the value of X. 4 times 2 is -8 equals 0. And X minus 7 equals 0. And if we move from here to the right side of the equation, X is equal to +7. And it's important that you have that sign in there because it tells you what the oxidation state is. And as you can see, it's pretty straightforward to figure out the oxidation number for something. In this example, we have oxygen difluoride, which again, you don't have to know its name, but if we're trying to find the oxidation state for both of these elements, again, we don't even need to do any math because we already know that oxygen is always -2 and fluorine is always -1. However, I just want to show you how we can figure it out by just looking at this. There's a shortcut for this, and the shortcut is really straightforward, and it's something that you might face in your life, and you have to be able to kind of recognize it quickly. As you can see, I'm only multiplying the 2 by the charge in here and in there. And since we already know that they are located in the right side of the periodic table, their charges should be negative, and we already know that they are the elements that the charges are not going to change. And as you can see, oxygen is -2, and fluorine is -1. And again, you can see that I use this shortcut where I multiply the subscript by the charge for both of these elements, and both of them have a good charge or a oxidation state. Now we have this compound and we don't need to know its name again. And we are told that we need to find the oxidation state for Cr or chromium. Now, the easiest way to figure this out is to just remember where oxygen is located or if oxygen's oxidation state is going to change. And we know that oxidation state for oxygen is not going to change, so we know that chromium is something that we're going to solve for, so we're just going to put an X in here and O4, and we know the charge of oxygen is -2, and we know the whole thing has a 2 minus charge. As you can see, this charge is written differently, but you can basically write it as such. Okay, now all we need to do is to solve for X, which means X plus -2 times, again, since we have 4 oxygens, we have to multiply it by 4 equals -2, -8, -2, as you can see, the value of X is +6, which means chromium has a +6 charge. And we know that the overall charge is -2. And again, because we have an overall charge, this time I want to talk about how we get that -2. And if you think about it, if we add 6 plus -2 times 4, it should give us -2. And let's see if we get that number. 6, 4 times 2 is -8 equals -2, and -8 plus 6 is -2, which means -2 is equal to -2, which means our answer is correct. For our next example, we have H2SO4, and later when we do acids, we know that this is called sulfuric acid, but again, you don't know what its name is. And as you can guess, they want us to find the oxidation number for sulfur. And how did we guess it? It's because oxygen and hydrogen is located in the first group, and we know that they always have a +1 charge, and oxygen always has a -2 or -2 charge, which means the only thing that we're not sure about is the sulfur. And we need to solve for it. Now, the easiest way is to just write down every single charge with the subscript. We don't know this one, it's X. We know that's -2. And the whole thing should equal 0. Now, first we need to multiply these two. +1 times 2 plus X plus 4 times -2 equals 0. 2 plus X plus -8 equals 0. And 8 minus 2 is -6, 0, X is equal to 6. As you can see, our oxidation number for sulfur is +6, which means this is how you should show it. And again, if we multiply everything out, everything should give us 0. 2 times that, 6. 4 times -2 is -8, and 6 plus 2 is 8, minus 8 equals 0. Because the overall charge is 0, our answer is correct. Now, carbon dioxide is also one of the most popular ones that you breathe out every day, every single time you breathe in and breathe out. Now, we need to find the charge of carbon in this example, because again, we know that oxygen is always -2, which means I'm just gonna put an X in there 2, negative 2, and the whole thing should equal 0. X plus negative 2 times 2 equals 0. X, these two, negative 4 equals 0. X is equal to plus 4. As you can see, this time carbon's charge is plus 4. And if you remember from my last video, I told you that every single element in that specific column, they can either have a plus 4 or a minus 4 charge. And that's it for this video. Thank you.